So what we want to do is look at an example of utilizing the equation of a circle and utilizing some information about the circle. One thing you're going to be asked to do is to write the equation of a circle. With diameter, sorry, not diameter, with center, -2, and radius 7. Now I'm assuming you guys can do this relatively speaking pretty quickly. Write the equation of the circle with center of 5, -2, and radius of 7. And right now, what I'm looking for is something like this. Pretty much as straightforward as that. How many got that right? That's what I was expecting, but it's good to know that happens. Questions at this point? Okay. So, from that stage, we want to add a little bit of a layer of complication to it. And instead of giving you just the direct center and giving you the radius, maybe I want you to write the equation of a circle, and I might give you diameter endpoints. So it's a little bit more work to do. So write the equation of the circle with diameter endpoints. Five, 2, and 8, -4. So how is this one different than the last one? And we have neither one of those pieces of information that really help me write the equation itself. Can we somewhat quickly find the center of a circle, knowing this information?
Midpoint formula.
All right. Anybody remember off the top of your head the midpoint formula?
That'd be x1 minus x2 over 2, all divided by 2.
Okay. Basically, it's the average of those diameter endpoints. Right? So to find the center, we're going to take 5 plus 8 divided by 2, and we're going to take 2 plus -4 divided by 2. The average of the diameter endpoints. This is midpoint formula. And so that's 13 over 2 and -1. So that was right. Check the arithmetic. That's what you got. That's good. So information-wise, what I actually know right now is x minus 13/2 squared plus y plus 1 squared equals radius squared. I want to find the value of the radius, so I can plug it in there for radius squared.
Can you use the distance formula?
I can use the distance formula if I want to. That's one way to do it. And yes, if I find the whole diameter and divide it by 2, that's the radius. That's another way to do it. But I want to suggest to you this. I know that this is a point on the circle, and I know that this is a point on the circle. It's diameter endpoints. It has to be. That means it's specifically an x and a y number that fits in this equation. So if I want to, I can say 5 minus 13/2 squared plus 2 plus 1, the quantity squared, is equal to the radius squared. Instead of going to some other unknown formula that I have to remember, I can utilize this circle equation. Some of you are going to realize all of a sudden that this is actually just the distance formula. Remember I said it's the locus of points that are equidistant from a fixed point? This is the distance formula. Any different? So let's see, 5 minus 13 halves, is that going to be something like negative 3 halves squared, which is 9 fourths? Plus 9 equals r squared. So let's see, 45 fourths is r squared. 11.25, for those of you doing decimals. R squared.
11.25.
11.25? No, 11.25? Okay, second question is, do I need to find the square root of this?
No,
Why not?
because you're already, once you put it back in the original equation, it's just going to be that. Oh, yeah.
Yeah, I just need to know what is r squared, not what is r. So I know you guys just love to do algebra. So every once in a while, let's remember not to do extra algebra if we don't have to. So we end up having x minus 13 halves squared plus y plus 1 squared equals 45 fourths. A little bit of a different way, and that's it. That's the equation you're circling. That's it. Questions about this one?
Do you prefer fractions?
You know what?
Do you prefer fractions?
I do prefer fractions.
So we use fractions.
I like to use fractions, yes.
You mind if you like draw a triangle based on the points?
No, that's fine.